Hello everyone, we are going to talk about teaching mathematics through problem solving. I'm going to share my screen with you. And here we go. All right. Okay, so this is module 3, and again, we're talking about math and problem solving. And our goal is, you're going to teach and plan teaching and learning experiences and create a learning environment which promotes questioning, exploration, and problem solving, and also allows for individual differences in students. So I'm hoping that your service learning opportunities will help you be able to practice these skills as well. Okay, so I want you to think about tasks and problems that you could propose to children, and think about how you can facilitate that conversation. How can you support children's use of a variety of representation? So how, when they represent their thinking and learning about math. And these are the things that I want you to think about as we go through this presentation, and also as you read chapter 2 of Van der Waal. So Van der Waal also talks about this upside down approach. So the problem is presented first, and then the ideas and skills emerge from this. So children do not always learn from do as I say approach. So we want to really think about how can we get children to learn through exploring and figuring things out for themselves. So one of the skills we want to have them learn is the productive struggle. So many times we want to come to their rescue and answer their questions and just tell them the answer, but that's not what we need to do when we're trying to encourage them to be thinkers, critical thinkers, and problem solvers. And these are skills that they'll use for a lifetime. Okay, so in the book, in chapter 2, we talk about Tatiana's birthday, and her birthday's today. Happy birthday, Tatiana. She's turning 5. Her mother has green and blue candles, and so a problem would be, how many different combinations of green and blue candles could the mother use on the cake if she's putting 5 candles on the cake? So I want you to think about how you could present this to children and what kind of skills children will be learning from this activity. And again, this is something that I want you to think about as we go through here. So how can we present problems like this to children to get them to think and to also be able to explain their thinking? So goals of a problem approach. So we want to focus on children's attention on their ideas and making sense of math. So we also want to emphasize those mathematical processes and practices that we've talked about already in this course. So what process standards are addressed in the problem-solving approaches? We also want to make sure that we develop children's confidence, and there's lots of different ways that they can solve problems. And there's not just one way to solve a problem. We also want to allow for the what if situation. So when we go back and think about Tatiana's birthday, could there be 0 of one color candle and 5 of another color candle? Maybe a child hasn't thought about the idea of 0. So that's something that we can talk to them about. And also all the different ways that we can make 5, right? So 2 and 3 of, 2 blue, 3 green, 3 blue, 2 green, and all the other ways that we can make 5. Okay, so if you take a look at table 2.1 in our chapter 2, it talks about the 8 mathematical teaching practices that support student learning. And it also tells you what the teacher can do to enact that practice. And I really like this table. I like this book a lot, and I feel that it's one of those books that you could really use later on after this class is over. You can pull out this book while you're teaching children and get some really good practical ideas. So that's one reason why I continue to use this book. But again, I want you to take a look at the table, review it, and reflect on how you can integrate these approaches while teaching math. We definitely want to help children make connections to what they're learning and be able to have conversations about what they're learning. And then also, as teachers, our job is to pose purposeful questions. So if we see that maybe they're missing something or they need to think a different way about something, that's when we can have those questions planned. And then also tell them that we want to see how they're thinking. We want to hear how they're thinking, and so that they can share those ideas. Lots of different ways to support children as they learn math. Oh, oops, sorry. Features of a problem. So any task or procedure when children have no prescribed or memorized rules or method. There also should be no perception that there is one specific correct answer. Again, we want children to really think and explain their thinking. We want to engage children where they are. And of course, the problem must result in children learning. And we also want to make sure when we give them a problem that we require justification and answers to how they thought through their problem. This video, I would like you to watch. I'm not going to run it right here through this presentation, but it is available for you under videos in this module. But it provides an example of problem solving in math and this whole idea of posing worthwhile tasks. So within chapter 2, we talk about, make the task worthwhile for children. Children, we don't want to underestimate children. We want to provide them with real problems to solve, to think through. And this is a good example of that. So again, we want to think about this level of cognitive demand. We want to, of course, like I just said, pose worthwhile tasks. We want to engage children in productive struggle. We don't want them so frustrated that they don't want to continue to learn, but we want to challenge them to think. And then we also want to support them through their thinking. Cognitively demanding tasks challenge children to make connections, and then this requires higher order thinking. One way to really help with this higher level cognitive thinking is and worthwhile tasks is to provide children with opportunities to have discussions with each other. So they need opportunities to describe, evaluate, share, and make conjectures. They need opportunities to hear each other's ideas and to be able to clarify their own ideas. We want to, again, emphasize reasoning and encourage students to dialogue. Talk moves is something I believe we covered in the last module, and if not, it's something that we will cover. But basically, providing students with opportunities to extend conversations and have richer conversations about learning. So this is a hard question. How much should we tell or not tell, right? For me, I don't like to see people struggle. I'm a teacher, I'm a nurturer, I'm a mother, I want to help people. But sometimes it's that whole idea of a productive struggle. We want to introduce mathematical conventions, symbols, terms, but after concepts are developed, not before, and only as a way of labeling or explaining. So we want to also discuss alternative methods, but we do want children to learn and discover and figure things out themselves. And we also want to clarify the methods they're using, and help them make connections. That's really important. So promoting representation. So again, this is something, one of those process standards that we want children to develop. We want to encourage flexibility in how they represent their thinking. So it could be in drawings, using graphs made from stacked objects, timelines, pictographs, or symbols. We want to give learners something they can explore, something they can reason and communicate as they engage in these problem-based tasks. But we want to be flexible when we do that. So what if it doesn't work? Again, we don't want to tell them the answer. If it doesn't work, maybe step back, offer a simpler and related task. And if it doesn't work, then maybe set it aside and come back to it. Reflect on why it didn't work and reflect on other ways maybe you can help them understand the concept. You know, maybe if they're not understanding that concept, is the reason that they're not understanding that concept is because they haven't grasped another concept that underlies it. So I remember specifically helping a child with telling time, and I ended up drawing the clock, I think, on a paper plate, or I did something and showed him something, and it was like he had this aha moment. And you know, he said, wow, thank you so much for explaining this. And he figured it out himself, but I gave him some methods to think through it and step back a little bit. And I think, you know, that really does help. So the 3-phase lesson format is really interesting. So there's also a podcast that's listed here and also is linked in Blackboard. But there's 3 takeaways that the podcast points out. And also, if you see table 2.5 in chapter 2, it goes into more detail. But before you start a lesson, allow children, we should explore the problem ourselves. Like so many times, you know, when we're running out of time, we just say, okay, here's what they need to do. It's in the curriculum. Do this. But if we haven't yet done it ourselves, we might not be able to anticipate some misconceptions or some things that students might do while doing the problem. So the best thing for us is to do it ourselves first. And then during the phase, that's time for us to explore how students are thinking, looking over their shoulders, asking questions like, oh, why do you think that is right? Or can you explain your thinking? The after phase is a time where students can share solutions and strategies and have them make connections between their strategies. That's really important too. Oh, I also want you to take a look at this article of how teaching math differs in other countries, because it is really important for us to understand that math is not always taught the same way. So that when we have children that may be from different countries, we need to really understand that. Singapore math is another math strategy that is supposed to be very popular and has been adopted in the United States in many places. But the heart of Singapore math is this whole idea of problem solving. So I did want to point that out. I'm also sharing with you an interesting article regarding using gradual release of responsibility in math. So before it was, you know, I do, we do, you do, with this gradual release of responsibility. But as we're talking now, research suggests that allowing children to explore and discover might be the way that we want to think about teaching math, and rethinking this whole idea of the gradual release of responsibility model. But it is important that you know about the gradual release of responsibility model when it comes to teaching math. So please let me know if you have any questions or comments, and take a look at those videos, take a look at those resources and the podcast that I mentioned in this video, because it will help you through this module. And I welcome your questions and comments. Thank you all.